Okay, so you can look at the notes. Notes will be over here, right? Page 31. So when you want to solve a radical equation, you need to isolate, right? You have 3 steps here. Isolate the radical. Isolate and then square both sides. When you square the both sides, you need to put brackets around the whole thing. And make sure at the end you have to check your answer. Sometimes you need to throw away, reject. Okay, one of the answer. All right, so let's take a look at that question. So let's say if we are doing 52, so Jenny, what's our first step?
Move the 8 to the other side.
That's right. So it becomes root r plus 4 and r minus 8, right? You got that part?
Yeah.
Okay, and what do you do next?
And then you square both sides.
Right, so make sure you have a bracket, square the whole thing. Okay, so the left side, it will cancel out the square root, so you just get r plus 4. And how do you square the right side?
So it'd be r squared minus 16r
Yeah, very good.
minus 16.
Should be plus
Oh, right.
plus what?
Plus 16. No, sorry. 64.
That's right. Okay, so square b squared, right? It's using the formula. So once you get to this point, this is a quadratic equation now. No more radical. So how do you solve a quadratic equation?
So you move the r plus 4 to one side.
That's right. Okay, make everything equal to 0. Right. So what does it become?
It becomes
Move
r squared minus 17r
yeah,
plus 60.
plus 60. Very good. Okay, plus 60 equals to 0. And do you know what to do after that?
We I forgot the name of it, but we try to get r squared and 60 to like
Turn it into 2 brackets.
yeah,
So this is called factoring.
right, factoring.
Yeah. Okay. Do you know how to do the factoring for this? Okay. Let me know when you found it.
Okay.
Okay, Jenny, do you need more time?
I think I have it, but like
Yeah, what do you have?
the signs don't work out.
Okay, what do you have in the bracket right now?
I have R plus 20 and R plus 3, but I don't think like it doesn't work.
Does it make the negative 17, right?
No.
Okay, so let's go over how you did it, or I don't know if you're doing the same way. I usually draw the two bars like that, right? Did you do it
Mhm.
this way?
Yeah.
Okay, so left side is just R and R. That part is easy.
Mhm.
Okay, so you said 2 and 30, right? So that one doesn't work. So
No.
yeah, okay. So what other combination can make 60?
20 and 3.
20, 20 and 3. Yeah, so 20 and 3, that still won't work, right? If they are, they will
Mhm.
add together to become 23, right?
Mhm.
Other numbers?
15 and 4.
15 and 4. Okay, that will make 19, right?
Mhm.
Okay, so
Oh wait, 12 and 5.
12 and 5, so that will make 17. But we want to have negative 17.
So negative 12 and negative 5.
Yeah, okay, so sometimes it just takes a bit longer, right? You have to go one by one.
Mhm.
So the two brackets are R minus 12 and
And R minus 5.
okay, equals 0. So from there, we can figure out R should equal to
It should equal to 12 or 5.
okay, so that's finding the answer for the quadratic equation, okay, but we need to make sure it also work for our original question, right? So you'll have to check. Do you know how to do the checking?
Yeah, just place the numbers in one at a time.
Yeah, one at a time and make sure if it equals on both sides. So
Mhm.
if it doesn't, you reject that answer.
Yep.
Okay, so 54 is same thing. 54, you have to move them over first and then move 3 minus x and then square both sides.
Yeah. Okay,
Okay,
thank you.
you're welcome. Okay, Naomi and Tony, do you have questions about the homework? I still don't have your homework yet.
I have a question on, hold on. 42 and 48.
Which page?
42 on page 37 and 48 is on page 36.
Okay, let's look at 42 then, okay?
Okay,
This one, right?
Yeah.
Yeah, so this one it already has just one square root on both sides. The square root is isolated, right? So for this one, you just start with square both sides,
okay,
okay? So if you square both sides, the square root will be gone,
yeah.
right? So what does it become then?
So it'll become 4 times the whole bracket p plus 1.
Mhm.
And then the other side would be equals 2p plus 3.
Yeah, do you know how to solve for p from here?
Yeah.
Yeah, okay, so you just solve for p after some steps, but make sure at the end you need to plug it back in to see if you can keep it.
Okay.
Okay, you know how to do the checking?
Yeah.
Okay. And then you said the other one is what?
48 on page 36.
48. 48. 36?
48 on page 36.
I think should be 34.
Oh, 30. Oh,
Right? Page 30.
34. Yeah, 34.
Okay, Question 46.
Yeah. No, 48.
Okay, 48. Okay, over here. So this one you need to rationalize, right?
Yeah,
Okay, so what do you need to multiply with? What's the conjugate?
I think it's √3 minus √2.
Yeah, very good. So top and bottom. Right?
Yeah.
And then, so
And
what
then
happens at the bottom?
the bottom would, because it's gonna be squared, so it'll be 3 minus 2.
Yeah, very good. What about the top?
The top one, I think it's √9,
What's rule 9?
3.
Yeah, so you just write 3 and then,
Minus √6.
yeah,
Oh, I could just do that. Oh,
that's all, right? And then you simplify it, leave your answer, okay?
oh,
Yeah.
I'm overthinking it too much.
Okay. And that's all?
And 52.
52, same page?
Yeah, same page.
Okay, so this one, what's the conjugate?
It's 3√7 plus 2√5.
Mhm. Okay, and then the same thing on the top, 2 rule 5. Okay, so what will happen in the denominator then?
The denominator will be squared, so 3 is squared, so 9
Mhm.
times 7,
What's 9 times 7?
63,
Yeah, very good. And then,
minus 4 times 5, which is 20.
yeah, okay. So that's for the bottom part. The top, you just need to expand 4 things because you have 2 times 2 times 2 terms. So you have to expand 1 by 1. Okay.
That's the part I just don't.
Oh, okay. Then we'll do one at a time. Okay.
Yeah.
So what's the first one?
The first one be 2√7 multiplies 3√7, right?
How does that equal?
So 6√7.
Oh, rule 7 and rule 7 will be just 7.
6√49.
What's rule 49?
7.
Yeah, so it will be 6 times 7.
Oh, 6 times 7. Okay.
Okay, so what's that?
That'll be 40. 42.
Yeah, 42. Okay, so that's the first part, and then continue. Multiply the second one.
So the multiplying the second one would be 4 root 35
Plus or minus?
plus.
Okay, 4 rule 35. Okay, and then let's go to the next part. Next part is starting with the root 5 to multiply.
The root 5 we get 3 root 35.
Okay, also plus. Right?
Yeah, also plus. Yeah.
And then last part.
The last part is 2 root 25, so the 25 gets squared, so it's 2 times 5, which is 10.
Yeah, so plus 10. Okay,
Oh,
and then do you see anything, because you have 4 terms on the top, do you see anything to combine together?
yeah, the 42 plus 10.
Mm-hmm. What's
And
that?
then you get 52.
Yeah, anything else you can combine?
And then the 2 square roots, the 3 root 35 and 4 root 35.
It makes it into,
Which makes it into 7 root 35.
That's right, okay? Yeah, so you're not just multiplying, you also have to add them or subtract them if possible, okay?
Okay.
And Naomi, do you have any questions for the homework?
No, I'm good. Thank you.
You're welcome. So Tony, you're all good?
Yeah.
All right. So make sure you finish them up before the end of class and then we'll move on, okay? We still have just one more topic, I think, one big topic.
Okay.
Yeah. So today we're starting on page 38. Everyone, please turn to page 38. Raise your hand when you are there. Okay, Kat, Naomi, and Wilson, are you on page 38 now? Kat? Are you here, Kat? Okay. All right, so let's take a look at what's in this topic, okay? It's called rational expression. Rational means anything that can be written as fractions. So that's why you see a lot of fractions here, right? Expression means it has variables, all right? So not just 2/5, it has a variable on the numerator and the denominator. So first thing we're gonna talk about is the restrictions. Because when you have fractions, there's always restrictions on the denominator, okay? And after we talked about restrictions, we'll learn how to simplify each fraction and then how to do operations between the fractions, okay? Operation including multiply, divide, right? And then we have on page 44, add and subtract. After we know how to do those operations, then we apply that to equations, okay? Solving. And once you know how to solve for the unknowns, we have word problem to apply to, okay? So that's our general outline for this topic. So today we will just focus on restrictions and how to simplify. Maybe do a little bit multiplying, okay, if we can get there. So let's get started. So when you have a fraction, what kind of restriction do we have? Either on numerator or denominator? Does anyone remember? Restriction means something you cannot do. What kind of restriction do we have on fractions? Anybody? What kind of things you cannot put in a fraction? Okay, we have put a 0. Shanier, can you elaborate that? What do you mean 0? You can turn on your mic. Restriction are in the denominator. Yes, okay, so 0, you can never put it in the denominator. You can write this down up here, okay? Restriction for rational expression is denominator cannot equal to 0. Okay, because it won't make sense if you want to divide by 0. For example, if I say I have 4, use something else. Use 8, okay? 8 divided by 2 equals to 4, right? If in a word problem, maybe they will say there are 8 candies, right? You want to divide it by 2 people, right? Share with 2 people, you get 4 candies for each person. But if you do divide by 0, then you can get an answer for that because there's no people there for you to share, right? How can you get an answer? How many does each person get, right? Because you are not sharing with anyone, right? So that's why you never put a 0 in the denominator. So this one, undefined. So undefined. Okay, so now we are dealing with rational expression. So meaning you have variables. So this part is just focusing on restriction. So if the numerator and denominator are both polynomials, then it is called rational expression. Restriction means the values that will make the expression undefined. So in this case, it will be undefined when denominator equals to 0. Okay, so we are looking for what kind of number will make the denominator equal to 0. So let's look at the first question, question A. Okay, so don't worry about simplifying. We're just looking for restrictions. So if you look at the denominator, we see there are 4 things are multiplying, right? 10, x cubed, y, and z squared. So you look at each part, right? Because anything times 0 will make the whole thing become 0. So you look at parts, okay? There are 4 parts. Let's write it down, 4 parts. Or 4 factors, okay? Maybe we use the word factors. Factors means they are multiplying, okay? So I want to find out what number will make each factor become 0. For the first one, the 10. 10 is a constant, right? 10 is a constant. Constant means it will always stays at 10 and will never become 0. Okay, so we'll ignore that part. The next part is the x cubed. Okay, I need to make sure the x cubed cannot be 0. So if x cubed cannot be 0, x cannot equal to 0, right? Because if I put 0 into x, x times itself 3 times, 0 times itself 3 times will be 0. The second part, which is the y cannot be 0. So this one is already isolated, right? No square, so you get y cannot be 0. The third part is z. Square cannot be 0, which means z cannot be 0. Any of these values, right? Any of the variable here, if it equals to 0, it will make the whole denominator become 0. So that's what we call these are the restrictions. Meaning they are the numbers that the variable cannot equal to. Okay, so first of all, you have to find the factors. And factors means they are the things that multiplies together to make the denominator. Okay. So let's look at the second example here. For the second question, look at the denominator. How many factors are there? Henry? How many factors for question B?
2.
Factors means things that are multiplying together.
Oh,
So what are multiplying together in the denominator?
3x.
Yeah.
And x plus 1.
And x plus 1, okay.
Oh,
And
sorry.
And also the 3x, I can split it into 3 times x as well, right?
Mm-hmm.
So actually there are 3 parts, 3 factors in the denominator.
Oh,
3 count as 1, x count as 1, x plus 1 is another one. So this one has 3 factors. But we will ignore the 3 because 3 is a constant, just like the 10, right? So that one will never become 0. We'll just look at the other 2 factors. So x cannot be 0, so that's already one of the restriction. The second, the other factor is the x plus 1. This one I cannot have it to be 0. And then isolate the x. X cannot be -1. Okay, so for x, because if x is -1, it will make the bracket become 0. And if the bracket is 0, the whole denominator, when they multiply, it will also become 0. Okay, so our restriction is this one and this one. Okay. Does anyone have questions here so far? You need to know how to tell how many factors that there are, okay? And then you look at each factor separately. Okay, can you raise your hand if you understand up to here, how to get the restrictions? Okay, Tony, Valerie, and Wilson, do you have any questions about finding restrictions? Tony, any question? Yeah, okay. So I would like you to try the following question A and B. Okay, at the bottom. Write out all the restrictions. Once you got the restrictions, you can raise your hand and we'll go over these two. Yep, sure, Jenny, no problem. Please raise your hand if you finish A and B. So if you're already on B, right, even though you see x plus 3 on the bottom, right, also x plus 3 on the top, do not cancel them out, okay? Because if you cancel it out, you will lose the restrictions. So you want to find all the restrictions even before anything crossed out. Okay, restriction for the original question. Okay, please raise your hand if you're done. All right, Geoffrey, for question A, how many factors in the denominator?
4,
Very good. Which 4?
7, x squared,
Mhm.
y, and x minus 3.
Very good. Okay, so this one we have 4 factors. However, we should only have 3 restrictions. The 7 is a constant, so it will never be 0. Right, so let's start with the x squared. X squared cannot be 0. Y cannot be 0. X minus 3 cannot be 0. All right, Aaron, what's your first restriction?
I put x equals cannot equal 0.
Yeah. All right, and Angeline, what's your second restriction?
Y cannot equal 0.
So that one, nothing changed. How about you also tell us the last one?
X cannot equal 3.
Yes, okay. So writing out, you can writing out like this out one by one. Okay, that's one way to write it. Or because you see the x cannot be 0, right? X cannot be 3. So you could also write it out like this. X cannot equal to 0, comma 3. Okay, so let's writing. And then you have the y cannot be 0. So you can either put your answer like this way, right? Restrictions, or list out one by one. Okay. Let's look at the second question, question B. So for the denominator, okay, Wilson, how many factors in the denominator?
Is there 4?
For question B,
Yeah, 4, I think.
okay, how many things are multiplying in the denominator?
Oh wait, no, two things are multiplying.
Okay, which 2 things?
2x minus 1 times by x plus 3.
Yeah, okay, so factors means they are multiplying together. Okay, so look at how many things are multiplying. So these are 2 factors. And there's no constant alone, right? So you get 2 factors that has variable, then you get 2 restrictions. First one comes from the first factor. Second one comes from the second factor. Okay, you just look for factors. All right, and yeah, what do you get from the first factor?
Hang on, sorry.
Okay.
X cannot equal to 1/2.
Yeah, very good. And Tony, can you find the second one? Isolate the x.
Which x? Which one?
We're on the second one, this one, the one is circled.
X plus 3 equals to does not equal to 0.
Yeah, and then you isolate the x.
So x does not equal to 3.
If you move the 3 over, it should become,
Negative 3.
yeah. Okay.
Okay.
Yeah. So the first one, right? From the first one, you move the negative 1 over, become positive 1, and then divide by 2. That's why it's 1/2. Right. So at the end, you can combine them together, right? Because they are both for x. So x cannot be half, cannot be negative 3. Okay. So you box that. That's your restriction. All right. So please raise your hands if you understand everything to here, right, make sure you copy down the work, the steps. All right, so let's look at question C. We skip question C, right? Because the denominator has not just the x, right? It has x and y inside, okay? So how do we deal with that? Sometimes they could have more than, they could have, I think maximum only get 2, right? Either x and y, sometimes you have a and b, okay? So when you have a mix of letters, 2 letters, you isolate only the first one, like in order, right? Like x is before y, right? In alphabetical order. So you isolate the x. So if it has a and b, then you isolate b. If it has P and Q, then you isolate P. Okay, so you isolate the first alphabet in order. All right, so for the question C, how many factors are there in denominator? Naomi, how many factors?
2.
Yeah, which 2? Can you tell us?
2x minus y.
And the
And
other?
3x squared minus 9y.
Good. Okay, so we take each one, make it not equal to 0. And then isolate the x, right? If you have a mix of x and y, you only isolate the x. So your restriction, it will have y inside. So we move the y over and then divide it by 2. Okay, so Tony, can you try this one? Tell us what does x cannot equal?
X cannot equal to hold on.
Move the y over.
Yeah, wait, hold on. Y element. It cannot equal to 1 over or 1/2 of a y.
Okay, so 1 over 2y.
Yeah.
Okay, yeah, you can write it like that, or you can just write as y over 2. It's just, okay, move the
Okay.
y over and then divide by 2.
Okay.
Okay, very good. Now the next one, if you want to isolate because it has a square, okay, so when you move the 9y over, it will become 3x squared cannot equal to 9y. All right, how do we proceed from here, Henry?
I think you should.
Mhm.
Oh no, never mind.
What's the next thing we can get rid of on the left side?
Oh, sorry. The 3.
Yeah, how do we do that?
You just divide it by 3 on both sides.
Okay, let's do that. So you will have x squared cannot equal to,
3y.
okay. And what's the next thing we need to get rid of? Our goal is to just have x, right?
Okay, so then get rid of the square.
Yeah, how do we get rid of the square?
Use square root both sides.
Very good. Square root on both sides. So it will become x cannot equal to what?
3y root.
Yeah, 3y in the square root. Okay, very good. Did I miss anything? Does anyone see what I missed here? Did I forget something? Anybody? I'm still missing, I forgot to do something here. Anyone? Geoffrey, can you see what I missed? Okay, Enya,
Maybe Y, a restriction on Y.
okay, for this one, a good point, okay, for this one, you don't need to isolate the Y because when you do the X, it already has the Y inside, okay, so yeah, you just need to isolate X. Okay, Shanier said plus minus, yes, okay, we are missing the plus minus. So the place where we need a plus minus is the moment I put the square root on, you need to have plus minus in front. Okay, make a note of that. That means it could be positive root 3y, could be negative square root 3y. So in total, you have 3 restrictions. Okay, so I'll explain on the side, how come we need plus minus, okay? So suppose we have x squared equal to 25. A number squared, a number times itself, that can equal to 25. So I will put square root on, right? So if you don't have the plus minus, then the answer you get is just 5, because square root of 25 is 5. So 5 times itself will be 25, right? However, negative 5 times negative 5 could also give you positive 25. So when you square root a square, you need to have plus minus. You have 2 possibilities, okay, for your answer. So this is something to pay attention to, okay? Why we need plus minus. All right, so at the end, let's make a conclusion here, right? X cannot equal to y over 2. X cannot equal to root 3y. X cannot equal to the negative root 3y. So you have 3. Okay, 3 restriction here. All right, so don't forget the plus minus when you put the square root on. We don't need the restriction for the y because it's already included when you're isolating the x. Okay, so I'll let you guys try question C now. So question C, by the look of it, right, you should also have 3 restrictions, right? So you can raise your hand when you're done question C.
Wait, Jason, I have a question.
Yeah, what's the
So
question?
for B, how
Yeah.
come it's x doesn't equal to 1 over 2? Shouldn't it be negative 1?
Okay, for this one, right?
Yeah.
Okay, so you understand we get how we get the 2x minus 1 cannot equal 0?
Yeah, yeah.
Okay, so we just from there we isolate the x. So first you move the negative 1 over to the right side. Right, 2x minus 1 cannot equal to 0. So you move this to the other side. When you move it over, you need to change the sign. Follow?
Yeah. Yeah, I
Okay.
know that.
X cannot equal to 1, right?
Right.
Okay, what's the next thing you want to get rid of now?
The 2,
And how do you do that?
you move it and then it's negative 2.
What's between the 2 and the x? What are they doing?
Well, they're multiplying.
Yeah, so if you need to do the opposite of multiplying. What's
Oh,
that?
so you divide it. Okay, I get it now. Okay.
Okay,
Yeah.
in order to cancel out the multiplying.
Okay, thank you.
You're welcome. Okay. All right, if you finish C, please raise your hand. Okay, remember to raise your hand when you finished. All right, so for this one, okay, we'll just check answer first. Bernice, can you tell us one of the restriction?
I got x cannot equal -2y.
Okay, very good. Isabella, can you tell us another one?
I got x cannot equals to 9y over 4.
9y over 4.
Mm.
And Henry, do you have another one?
No.
So you just have 2?
Yeah, I only had 2.
Okay. Jenny, how about you? Do you have anything different?
No, I got the same.
2 restrictions. Yeah,
Wait, sorry, what?
you have 2 restrictions as well.
Oh wait, no, and -9y over 4.
Negative 9y over 4.
Yeah.
Okay. Anyone else have different? Aaron, how about you?
I simplified the 9 over 4 to like 3 over 2.
So 3y over 2.
Yeah, it
Okay.
should be the same thing, right?
No, they are not the same. 9y over 4, 3 over 2 is not the same. And also the negative as well. Is it?
Yeah, it says it's -3 over 2.
Okay. So right now we have 5 different restrictions here, right? Okay, so let's go over, see which ones here will work. So the first factor is this part. I think everyone got that part right. Okay, second part is this one has the square. So x plus 2y cannot be 0. The other part is the 4x squared minus 9y squared cannot be 0. We isolate the x, so x cannot be -2y. So that part is easy, right? I got it. Next part, we want to isolate the x slowly. Okay, so we're gonna move the 9y over first. It'll be 4x squared cannot be 9y squared. And then to isolate the x, we first had to divide by 4 on both sides. So you get x squared cannot be 9y squared over 4. Okay, this time everyone remembers to put plus minus, right? Which is good. However, when you square root, you're square rooting the whole thing. Okay, the whole fraction. Plus minus. So you need to square root the 9, square root the y squared, square root the 4. Okay, so it should become x cannot be plus minus 3y over 2. 3 comes from square root of 9, okay? And 2 is from the square root of 4. So your restriction should be these two. Okay. So it doesn't just cancel out the square, you have to square root each of the number inside as well. All right, so let's take a break. If you have any question about the restriction, you can ask me or about your homework, okay? We'll continue the class at 2:40.